that line L and line M are parallel. So I would say line L is parallel to M. That little symbol means parallel. Alright, and then this line here is T. Anybody remember what the name for T is? Yes, just say it.
Transversal.
Transversal. So whenever I have a line that intersects two parallel lines, or two lines at all, it transverses. Actually, whenever you have two lines that intersect, they transverse. But in geometry, we use the parallel lines with the transversal a lot. So now when you do that, this creates a bunch of vertical angles. Okay? And so I'm gonna start with the I'm gonna start here. I'm gonna do right out of the book. I'm just gonna label these 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now there's a whole bunch of theorems and postulates, and so I'm just gonna go. I'm just gonna start listing these. So same side interior would be like angle 3 and 5. So if I said angle 3 plus angle 5, those are always going to add up to 180. All right? Always going to add up to 180. If lines L and M are parallel, the same side interiors will always add up to 180. Now you say, Mr. Adams, what do you mean by interior? Oh, I'm glad you asked. Interior are angles that are inside the parallel lines. All right? I'm going to use another term in a second here. Exterior. Exterior are angles that are outside of the parallel lines. Okay? So, same side, as you can see, angle 3 and angle 5 are on the same side of the transversal. Okay? Same side of the transversal. Likewise, angle 4 plus angle 6 will equal 180. Always. If L and M are parallel, this always occurs. Next one, alternate interior angles. Angle 3 is congruent to angle 6. Now we say alternate because you have one angle on one side of the transversal and the other angle on the other side of the transversal. So you have 3 here, and then you have 6 here. Those are always congruent. Likewise, angle 5 is congruent to 4. Those are alternate interior angles. Moving right along. Alternate exterior. I just did interior. Exterior. Opposite sides of the transversal on the exterior. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Okay? We're almost done. Now we went, I did a really long proof. You guys remember, you guys looked like zombies when I was done. Drool was hanging from your lips. It took about a half hour to prove all this stuff. At this point, I just need you to memorize this and know it. At some point later on down the road, I might ask you to prove some of those things. So now, that's the case here. I got one other type of angle that we probably should talk about. And that would be what we call corresponding. Oh, you guys can't see that way in the back, can you? No. Let's do purple. No, let's do gray. All right, so corresponding. Corresponding angles. Angle 1 is congruent to angle 5. Now we call them corresponding because they're on the same side, but if you think about it, angle 1 is kind of in the same position or location with regards to the transversal and L as angle 5 is with regards to the transversal in the line M. You see how they're kind of in the same spot? One is in one spot with L, the other one's in the same spot with M. That makes sense? Yes. And so now all of the corresponding angle, and they're always on the same side of the transversal. So angle 3 is congruent with angle 7. Angle 2 is congruent with angle 6. And angle 4 is congruent with angle 8. All right? Does that make sense? Yeah. Now, when we do constructions, and that word means two things. Construction means to make a shape or something through geometric means, drawing lines and measuring angles and all that stuff. We also, that's, by the way, it's no accident when we construct a building, we use that same term, construct, because that's literally what we do. We will fall, this is very important. Just about every proof we use will have some sort of variation of this and the properties or corollaries or postulates regarding triangles. Because all shapes can be broken down, well, most shapes can be broken down, at least at the high school level, is some sort of parallel line transversal thing or as a triangle. When you think about it, any angle you make is the corner of a triangle. So we can extend or create a third extension to make 3 sides. And that always gives us the triangle, that gives us properties. Same thing with the parallel lines. For some reason, human beings like to make things parallel. This room has 2 sets of, well, if it was a perfect square or rectangle, it would have 2 parallel lines. That wall in the back is should be parallel to that wall there. The flat wall where my bulletin board is should be parallel to where my whiteboard is, right? So you use all these properties to make sure. Okay. All right, so we need to know that. That's the first thing we need to know. Now in example number 1, so I did all that stuff to say example number 1. It says angle 3 equals 55. Which angles are supplementary to angle 5. Okay. So angle 3 is equal to 55 degrees. Which angles are supplementary to angle 3? Now, I've never seen this before ever in a textbook, but this is how Mr. Adams teaches it, and I think it's very helpful. When we first started my proof, I said the parallel line transversal thing, you have 2 sets of angles. What did Mr. Adams label those 2 sets? Big and small, right? Very informal. Think about this. Is number 3 a big or a small?
Small.
Small. Now what I mean by that, big angles are usually obtuse, greater than 90 degrees. Small angles are usually acute, less than 90 degrees. So now, here's what I want to, using Mr. Adams' terminology, a big angle plus a small angle on this parallel line transversal situation are always supplementary. They always add up. Okay? So, which is 3, a big or a small?
Small.
Small. So, what angles are supplementary to 3? Yeah, it would be all the big ones. So, I will circle them. You tell me what they are. Tell me.
Angle 1.
Angle 1 certainly is, yep.
4.
4 is, yep.
5.
5.
8.
8.
It's a zigzag effect.
Okay. That's it. That's it. Now your book is a little more formal, but it would be angle 1, angle 4, and your book had a different picture, and I apologize. Just write down what I have. It makes sense. Okay. They had their parallel lines orientated vertically. I think the numbers may not have matched. Now, if I look at that, It supports basically what we claim in a roundabout way. We said that angle 3 and angle 5 were supplementary, right? Well, also keep in mind that angle 1 and angle 5 are congruent because they're corresponding angles. So I could easily plug in angle 1 here using the transitive property, right? Because angle 1 and 5 are corresponding. And we might do something like that. In fact, when we start to do some proofs with this stuff, we will. But if you keep in mind that a big plus a small equals 180, all the smalls are congruent, all the bigs are congruent, you can't get the problem wrong. Okay? Yes, question?
You said which angles are supplementary to angle 5. How is angle 5 supplementary?
Oh, I wrote
Or
down,
is it supposed to be 3?
yeah, it's supposed to be supplementary to 3. Remember, the original question said angle 3, right? And I don't know why, I wrote down angle 5 because I knew angle 5 was one of the answers.
So why is
But how do you
it supplementary to angle 1?
Well, for example, angle 3 is supplementary to 1 because it's a linear pair. And by definition, they share the same line, they share the transversal, so they're going to be supplementary, right? Well, what is angle 1 congruent to? Well, it's congruent to angle 4 because they're vertical angles. So that means angle 4 is also supplementary. Also, angle 4 is a linear pair on line L. Well, now, 5 is a corresponding angle, which means it's congruent to 1. And if 1 is a linear pair and it's congruent, then 3 plus 5 would equal 180. And then again, angle 5 and angle 8 are vertical angles, so they're congruent. So that's how we get all that.
So why don't you have angle 2 too?
Well, angle 2 is congruent to 3. So it doesn't mean it's supplementary. Does that make sense?
So, because you're saying they share the same line, so it's angle 1 and angle 3 share the same line.
Right, so remember that a linear pair, if I have a straight line like this, and I have an angle here and an angle here, that's a linear pair because they share a line.
And they equal 1.
Yeah, but we got a whole bunch of lines up there, right?
But you couldn't do 2 because that goes 2. If it was like, since
2
it equals 55, they don't equal.
Yeah, so 2 technically isn't on the same side of the line as 3. So like 3 and 1 are on the same side of the transversal on that side. 3 and 4 are on the same side of this line. So that's why. So you have 2 linear pairs just because of the intersection. Now, angle 2 is not on either one of those sides with 3. Does that make sense? So I can't use that linear pair rule. And in fact, we used this property when we proved that vertical angles were congruent. Right? So angle 3 is congruent to angle 2. The only way that they could be supplementary is if that transversal was at a 90-degree angle with L. Because then you'd have 90 degrees plus 90 degrees.